All right, we're back. We're on page 186. We're talking about parametric equations for lines and moving things from a point to another point, things like that. So as you get more context to the problem, you start having fewer and fewer options, to be honest. So like in the previous page, all we really knew was a point that had happened to go through and a slope. So we're free to do whatever we want as long as delta y over delta x works. We could find another point that was on the line and use that, which we did here a couple times. Whatever happened, we just needed to get the equation of a line. Well, what if we need something more specific? So instead of a whole line, what if we just need to move from the 0.38 to the 0.9 negative 4, and then we want to stop, right? So now there's a couple of considerations. The first one is that I need to start at 3 and end at 9. Like I can't just arbitrarily be like, oh, delta x is 5 and then figure out what delta y is. Well, I mean, I could potentially do that, but I don't want to like mess this up all that much. So let's start out, and I'm going to say that delta x to get me from 3 to 9 is 6, and delta y to get me from 8 to negative 4 is negative 12. Okay, so I'm going to say a set of parametric equations that can make this happen. I have to start at 3, 8. It's not an option to start anywhere else because it says we're moving from 3, 8. We have to end at 9, negative 4. Not an option to do anything else. So I'm just going to say plus 6t minus 12t. And if I do that, if I use delta x once, I get from 3 to 9. So t just has to be between, So t is between 0 and 1. That'll do it. Like that's all I need to make this happen. I can start getting more creative, potentially. So I'm going to say that this is the answer I'm going to go with, right? But I'm going to get a little more creative just to like show you what can happen. You know, what if you wanted to go, what if you want to go faster? What if I say delta x is 12? So I double delta x, and delta y I have to double as well. So negative 24, just to keep the ratio the same, right? Delta y over delta x has to be negative 2. So I doubled delta x. So doing that means it should take half the time. So I'm going to say now that x is 3, y is 8. All right, so it's got to be plus 12t, and then minus 24t. But in this case, t has to start at 0 because that'll give you your 0.38 where you're starting. It's going to stop at 1/2. Stops at 1/2 because I really only need 6 and I have 12. So doubling delta x, I halved the time. If I triple delta x, I would 1/3 the time. If I cut delta x in half, so if I say delta x is 3, so I'll do this. This is the last one. The last one I'll do this. Delta x, delta y. If I say delta x is 3, then delta y is going to be just negative 6. And my equation is going to be 3, 8. So like I really believe you can like logic these out, which is why I'm not like I'm not explaining over much, like too much what I'm doing here, because I think that playing around with it is really the best way to learn this. So here is 0t. So it used to take 1, but now I'm going half as fast, so it's going to take twice as long. So it's got to go to 2. So let's take a look at pretty much all of these. Let's just go to GeoGebra and graph them and see what happens. So I'm going to go to GeoGebra, and then I'm always choosing GeoGebra Classic. And when it loads, first thing I'm going to do is I'm going to click here so that this doesn't like obscure that first line. Click there, and then I want to do, you know what I'm going to do? I'm going to plot the 0.38. I'm going to plot the 0.9 negative 4, so we know like where to start and where to stop. Like that's the idea of like, so we want to go from the point A and end at the point B. All right, let me make a slider. I'm going to call my slider T, and I'll set it to start at 1. And ultimately, I'm going to need, so the most anything took was 2. So 0 to 2, I want a small step size. I think we'll find out how that goes. All right, so curve number 1 is going to be 3 plus 6t, comma, 8 minus 12t, comma, oh, I'm using t, I'm supposed to be using v. Man. V, and then v is the parameter. We're going to go from 0 to, so this one, it's really supposed to go from 0 to 1. And you can see if I go from 0 to 1, if I go from 0 to 2, it goes past. If I go from 0 to 0.5, it doesn't make it. So 0 to 1 is what I need. Now I can put a point on there. I'm going to go a of t. And so if I hit play, you can watch a weird thing happen. Because c is just a of t, it's actually going to go past point b when this t value is above 1. So watch that happen. And you're like, that's weird. So you can fix that. This is like an advanced thing when you're trying to like make things look good. Just do a of the minimum of t and 1, because it should really stop when t is equal to 1. So now what'll happen is it'll move as long as, so right now the minimum of t and 1 is 0.25 because t is 0.25. And then right now the minimum of t and 1 is 0.7 because t is 0.7 and that's smaller than 1. Here, the minimum of t and 1 is 1 because t right now is 1.24, so it just stopped. It's always a of the minimum of those. So it stops. That's kind of like an advanced thing when you want to make something stop. So I'm going to hide this so that we can see if our next curve is right. So curve 3 plus 12t, v, 8 minus 24v, v is the parameter. I want to go from 0 to, so in this case I said 0 to 0.5. And you can see it's right. So if I do 0 to 0.4, it's not enough. 0 to 0.6, it's too far. 0 to 0.5. And I'm going to put a point. I'm going to do b of, so I want to do b of the minimum of t and 0.5, because when you get to 0.5, it should stop. So I have this, and I'll hit play. And you can see point d is going faster, as it should, because it only takes 0.5 to make the whole journey. When I get to 0.5, d will stop, and it's not going to keep moving. And then finally, when we get to 1, c will get there and stop. And then the timer keeps going because we did one more. So let's put that one in. Curve, let me hide that curve. Curve, and it's going to be 3 plus 3t, v, 8 minus 6v. V is the parameter from 0 to 2. And you can see we got it. If we go 0 to 1, not enough. 0 to 2.5, too much. 0 to 2. All right, and then we will put a point on that. C, so that the whole slider only goes up to 2. I mean, I'm going to do it anyway, just in case we like adjust this. The minimum of t and 2. So we got our point. I'm going to hide this. I'm going to hit play, and you can see all 3 of them accomplish the goal in different time frames. 0.5, that one's done. At 1, this one's done. And then finally, eventually, when we get to 2, this one will be done. So this is pretty cool. This is like how we're going to work these things out. I'm going to go back to the notes. And I actually think I'm going to maybe stop this video here because that's a lot to think about. So what I would do if I were you is like create 2 new points and try to do it again and see if you can like work out a couple of them. See if you can make it take a certain amount of time, like 5 seconds, 10 seconds, see if you can get that like minimum of thing to work. There's a lot going on there. Play around with it. It's definitely the best way to learn. So I will see you in the next video when hopefully you have played around with this for a while and you're ready to take on this next challenge. So I will see you there.